In this video, let us discuss about source-free RL circuit. So this is L means it is an inductor, and R means it is a resistor. So the condition is we have an idea that the inductor current will not change instantaneously. Okay, so let us assume at t is equal to 0, the inductor current, that is the initial current flowing through this inductor is I naught. Okay, so I of 0, okay, that is equal to I naught. So so this is how it is. Okay, so the energy stored in the inductor, let me term it as W of t, that is equal to 1 by 2 L I naught square. Okay, so if the voltage across this one is VL, and if this is V naught, I can write what is V naught. V naught is equal to minus VL. Okay, from this I can write V naught plus VL is equal to 0. Okay, so what is V naught? V naught is equal to the current flowing through this one is I. Let me take it as I. So I into R plus what is voltage across inductor L di by dt, that is equal to 0. Okay, so let me bring the, so from this I can write it as L di of d by dt is equal to minus I R. Okay, so di by I is equal to minus R dt divided by M. Right, so I can write like this. So if I integrating on both sides, okay, so the initial value is I naught, and the final value is I of t, right? And here it is from 0 to t. So if I integrate, I will get ln of I, right, from I of t to I naught of I naught, that is equal to minus R by L of t. This is from 0 to t. Okay, so this I can write it as ln I of t, okay, minus ln I naught, that is equal to minus RT divided by L. So this I can write it as ln of I of t by I naught. Okay, that is equal to minus R by L of t. Okay, so on taking power of E on both sides, if I take power of t on both sides, I of t by I naught is equal to e power minus R by L of t. Okay, so that I can write it as I of t is equal to I naught into e power minus R by L of t. Okay, so this I can write it as I naught into e power minus t divided by tau, where tau is a time constant. Okay, so what is tau? Time constant. tau is equal to L divided by R. This is an important formula. So what is now VR? VR of t. VR of t is equal to, we know that I is I into R, right? So what is I now? I is I naught e power minus t divided by tau into R. So this is VR of t. So what does mean by power? Power is equal to voltage into, that is voltage into time, right? So here VR is this one, I naught e power minus t divided by tau into R. Tau into R into I naught, I is I naught into e power minus t divided by tau, right? So this is nothing but I naught square R into e power minus 2 t divided by tau. This is your power. Okay, this is a power dissipated. Okay, power dissipated in the resistor. So what is the power absorbed by the energy absorbed by the resistor? Okay, if I want to find energy absorbed by the resistor, we know that so WR of T, that is energy absorbed by the resistor is equal to integration of 0 to T P of lambda into d lambda. So P of lambda is, I can write it as I naught square 0 to T I naught square R e power minus 2 lambda divided by tau d tau. Okay, this is d lambda. So I'm going to take I naught square R common, and I'm going to integrate 2 lambda e power 2 lambda divided by tau into d e power. So I will get I naught square R. Okay, if I integrate e power minus 2 lambda by tau is divided by minus 2 divided by tau. 0 to t is your limit. So I'm going to substitute this t value and 0 value for lambda. So if I substitute, I can write minus tau 2 tau divided by 2. I'm going to substitute t for lambda and 0. Okay, so minus I naught square R tau divided by 2 e power minus 2 t divided by tau minus e power 0 is 1, right? So and you know that tau is equal to L divided by R, right? So R get cancelled out, and this is e power minus 2t divided by tau minus 1. So this minus will go inside, and I can write the energy dissipated by the resistor is equal to I naught square L divided by 2 into 1 minus e power minus 2t divided by tau. Okay, so at t is equal to infinity, okay, at t is equal to infinity, omega r of infinity is equal to 1 divided by 2 L I naught square. You see, L I naught square e power minus infinity is 0. Okay, so e power minus infinity is 0. Anything power e power minus infinity means that is 0. So if you substitute, you will get 1 divided by 2 L I naught square. So this is nothing but WL of 0. Okay, so I can write the energy stored in the inductor, that is WL of 0, that is equal to energy dissipated by the resistor, that is WR of infinity. Okay. So at t is equal to 0, the energy gets stored in the inductor, and at t is equal to infinity, energy get dissipated. So the total so here the energy conservation get followed, right? So I can write I of t, it is IL of t is equal to I naught into e power minus t divided by tau. I can write I naught, or I can write I of 0, right? So first of all, you have to find the current flowing through the inductor whenever this kind of circuit is given. So we will discuss some problem on this also. So we will plot the graph for I of t and versus t. Okay. So if I plot at y-axis, I have I of t, and x-axis I have t. Okay. So if at t is equal to tau, okay, if t is equal to tau, I will get I of t is equal to I naught into e power minus 1, right? So what is e power minus 1? E power minus 1 value is 0.3 something. Okay. So if this is tau, and what is I of t? I of t is equal to 0.368 I naught. Okay. So at t is equal to 0. If I substitute t is equal to 0, I will get I of t is equal to I naught, right? Because I naught into e power 0 is 1. Next, I can substitute t is equal to infinity. So at t is equal to infinity, I will get I of t is equal to I naught into e power minus infinity. E power minus infinity is 0. So it will goes to 0 at t is equal to infinity. So this is how the circuit is. Sorry, the graph is. Okay. So if I want to find the in-between value, you can find the value for t, right? If t is equal to 2 tau, 1 by 2 tau, like that. So next we will discuss some problem. Assuming I naught is equal to 10, calculate I of t and I of x of t. This is your circuit. So you can see I have a dependent source. So here I can write I naught. This is so I have to replace this inductor by a equivalent resistance. Okay, so I can write RTH is equal to VTH by I naught. So this VTH, so I naught, you see it should be go outwards. So I can give the value of VTH is equal to 1 volt, that is across the inductor. Okay, so once this circuit is formed, we can use a mesh analysis to find the value. So what is I naught? I naught is equal to minus of I, right? So from the first so you will get let me copy this one and paste this on the next page. So from the first mesh loop, I can write 1 volt is equal to 2 into Ix, right? So what is Ix? Ix is equal to 0.5. From the second mesh loop, I can write, so this is your first equation. So from the second, I can write 3I is equal to minus of 4, because it is current in the opposite direction. I naught minus Ix plus 2 into Ix. Okay. So minus 4 I naught. We know that Ix is equal to 0.5. So minus 4 I naught plus 4 Ix plus 2 Ix. Okay. So this is equal to minus 4 I naught plus 6 Ix. Okay. minus 3i, right? So we know that I naught is equal to minus I and ix is equal to 0.5. so if I substitute, I will get 4 I naught plus 6 into 0.5, right, plus 3 I naught, right. So on solving, I will get I naught is equal I naught minus I naught plus 3. So I naught is equal to 3. So I is equal to minus 3 in amps, right. So if I substitute I naught value, I will get 1 divided by 3 AC or RTH. So what is I of t? I of t is equal to I naught. That is the initial current. It's already given e power minus t divided by tau. So 12 into e power minus t divided by tau. Tau is nothing but L equivalent into R equivalent. So what is L value? L value is 1 by 2, right. So R equivalent is nothing, here you can see this L equivalent is 1 by 2 and RTH is 1 by 3. Here R equivalent and RTH are same. So if I substitute, I will get 3 divided by 2. So I substitute 12 into e power minus 2 by 3 of t. This is your I of t in terms of amps. So next let us discuss another problem. This is a circuit. It is also based on the dependent source. Okay. So here also you have to replace the inductor by its equivalent in order to find. First we need to find the I. Okay. And they are asked to find the value of I and VFX. And the initial current through the inductor is 12 amps. So we know the formula, right? This is the formula for the current flowing through the inductor. So let me term this is I naught. So this is I naught, that is IA minus IB, and this is IB, right? So I'm going to replace the inductor by 1 volt voltage source, and I'm going to read out the circuit again. After that I have to apply mesh rule. Okay. So I can write IA is equal to minus I, right? So for the first second loop, 2Vx is equal to minus of 2 into IA minus IB plus 6IB, right? So on solving, you will get this equation. So divide. So here for the second loop, I can write 1 volt is equal to IA plus 2 into IA minus IB plus 2Vx. So here you can see Vx is equal to Ia, right? So you can see Vx, I can write as Vx equal to Ia, right? So I can write the equation like this. Okay. So from this equation I can write here this is 3Ia minus 2Ib plus 2Vx. So this is nothing but so instead of 3Ia I can substitute Vx, so I will get 1 is equal to 5Vx minus 2Ib, and in the first equation if I substitute Vx is equal to Ia, I will get 2Vx is equal to 4Ib, so Vx is equal to 2Ib, and so you substitute this equation in the second equation, you will get 1 is equal to 10Ib minus 2Ib, so 8Ib is equal to 1 and Ib is equal to 1 by 8. So if Ib is equal to 1 by 8, Vx is equal to 1 by 4, right? So Vx is nothing but Ia. So I'm going to substitute RTH. RTH is equal to VTH divided by Ia. VTH value is 1 and Ia value is 1 by 4, so RTH is 4. So what is tau? Tau is equal to L equivalent divided by RTH. So L equivalent value is 2 and RTH value is 4, so tau value is 1 by 2. So I of t is equal to I naught into e power minus t divided by tau. I naught is 12, so you will get 12 e power minus t divided by 1 by 2. So I of t is equal to 12 e power minus 2t, which is in terms of amps. So if I want to find the value of Vx, Vx is equal to Ia, Ia is equal to minus I, right? So I will get Vx is equal to minus 12 e power minus 2t in terms of volt.